Hello and welcome to the start of our last unit. We're finally at unit 15. I called this day 0 because it's kind of a pre-day to the last unit, but in order to do statistics in Algebra 2, you kind of got to know all the statistics from Algebra 1. Since it's been a couple years since you've seen that, you might not remember some of it, so I wanted to make sure that you knew the important parts. So here we go. Hopefully you've downloaded this, fill in the notes as you go, because that'll help you with this. Summary. I'm just going to start reading here and make some notes. This distributions are described by the shape, either symmetric or skewed, the center, and the spread or variability of the distribution. Each of those have some specific names that you've probably heard of before. A distribution that is approximately symmetric can look at different forms. So this is symmetric, nice looking shape. This isn't perfectly symmetric, but it's approximately symmetric. It's similar left and right hand side. The distribution is described as mound-shaped if it's approximately symmetric and has a single peak, like the example on the left. So another word for mound shape that they use sometimes, if I kind of like connected the tops of all these boxes, what's the shape look like? That's why they call it a mound. But you might have also heard this called a bell curve. We'll be talking a lot about bell curves in the next couple days. Okay, and then we also talk about distributions being skewed. A distribution is skewed to the right or skewed to the left if one of its tails is longer than the other. Now that can be a little misleading. If I kind of connect the dots here, would you say people might think that that's skewed to the left because more of the graph is on the left, but skewed means there's some values over here, some really, in this case, extreme high values that are pulling the average and median and things like that of all the data to the right. So it's skewed to the right because there's some values on the right that are affecting most of the values. Skewed to the left would look like this. So again, most of the data is on the right-hand side, but there's some extreme low values that are pulling the average and the mean and things like that. Those like data that, or the statistics that tell us about the data are getting skewed left, are getting pulled to the left because of these extreme low values. The mean of a distribution is interpreted as a typical value and is at the average of the data. So mean you want to think of as average always. And this is the symbol we're going to use for it. It's X bar. X with a little bar on top of it always means mean or average. The standard deviation is a value that describes the typical distance from the mean. Typical distance is going to tell you how spread out the data is. And that's represented by that symbol, which is lowercase sigma. Uppercase sigma was that. You don't need to write that down, but you saw that earlier this year a little bit. Okay. Let's talk more about standard deviation. It says consider the following histograms. Histogram 1, 2, 3, and 4 with the descriptions given below. Match the description of a distribution with the appropriate histogram. So there's your 4 histograms. Okay. Some of them are symmetric, some of them might be skewed. So we've got 2 that are symmetric, 2 that are skewed to the right. So which 2 would you say are symmetric? Right, 1 and 3. So this one, it's not perfectly symmetric, but it's approximately symmetric. 3 is pretty perfectly symmetric. Not exactly, but again, approximately. These are both skewed right because the majority of the data is on the left. There's some extreme high values that are affecting the mean and things like that. Now notice they all have the same mean, and that's why taken on its own, average isn't really the best indicator of what a distribution or what some data is, because all of these have an average of 100. When it's symmetric, that average is pretty much right in the center or right near the center. When it's not symmetric, it's still near the center of most of the data, but that data that's skewing it makes it kind of not in the center of the distribution. Okay, standard deviation. This is again how to tell how spread out it is. So standard deviation, these 40s down here are larger. If you've got larger standard deviation, so larger standard deviation means that your data is more spread out. Okay, so let's kind of look here. Look at your mins and maxes. This goes from 70 to, what's that, like 125-ish? This data here goes from like, that's probably 85, but then it goes all the way up to like 145. This one goes pretty easy to see, 0 to 200. And this one goes from 50 up to, it's pretty spread out. What's that, like 325? Okay, so we want to match these histograms. So histogram 1 is definitely symmetric. So it's either B or C. Does it have a larger spread for a 40 standard deviation or a smaller spread for a 10? Well, you got to find the other symmetric one. So compared to the other symmetric one, which one has a larger spread? Well, 0 to 200 is way more spread out than 70 to 125. So this is symmetric with a smaller spread. So symmetric, smaller standard deviation, histogram 1 would be B. By similar reasoning, histogram 3, which is this one down here, still definitely symmetric, but a larger standard deviation. So that's going to be C. Okay, so histogram 2 goes from 85 to 145. This goes from 50 to 325. So which one's going to have the bigger standard deviation? Histogram 4. So they're both skewed to the right because there's some extreme right values that are skewing the data. The smaller standard deviation is going to be histogram 2. So this will be A, which leaves D for histogram 4. Okay, so that's just a little visual about what standard deviation means. Next page. Okay, the histogram below shows the distribution of the greatest drop in feet of 55 major roller coasters. Would you describe this distribution of roller coasters' maximum drop as approximately symmetric or as skewed? Explain your answer. Sometimes it just takes drawing a picture in. Symmetric or skewed? Skewed. And it said to explain your choice. I would say it's skewed, and it's skewed right because there are some extreme right-hand values that are affecting the data. These big drops way over here are definitely going to affect the average and the spread of it. Is the mean of the maximum drop distribution closer to 90, 135, or 240? Remember, the mean should be right around the middle of where most of the data is. 90 is right here. Most of the data is bigger than 90, so that's going to make the mean go way higher. So 90 is too small. 135 right about here. That could be right in the middle of the data. But if you look at 240, it should be over here somewhere. 240 is way too big because there's only a couple roller coasters bigger than that. So yeah, that's going to affect the data a little bit, but it's not going to move it all the way. 100 might be right in the middle of the range of the data here, but since most of the numbers are lower, the mean's going to be a little bit lower too. So this is too big. So I would say 135, and let's use our symbols. X bar is 135 because the majority of data falls around 135. You could say a mean of 90 would be too small, and a mean of 240 would be too big for this data. So 135 is really the only one that makes sense. Standard deviation might be a little bit harder to find. Is the standard deviation, is the spread closer to 40, 70, or 100? Okay, well, now that you know where the mean is, let's lock that in. The mean we said is about 135, so right about here. If the spread was 40, there's a spread of 40. You're going out to about 175, and you're going down to about 95. Now, you don't know this yet, but approximately 68% of the data should be within one standard deviation of the mean. There's way more data that's outside. So 40, maybe. Let's look at some other ones. 70. So if I went 70, we'd get to about there, 200-ish. And 135 minus 70 be like 55-ish, right about there. Would you say most of the data is in that blue range? Yeah, this is kind of where the big chunk of the data is. And then finally, if you want to look at 100 hours, so up to 235 would get you to about here, and down to 35 would go way past the lowest. At that point, the only thing outside of the standard deviation would be these extreme high cases. So it's a little bit too big. So if you go on that, and we'll talk more about this in the next couple of days, if you go on that recommendation that about 68% of the data should be within one standard deviation, I would say the blue line is the way to go. I'd say more than half the data is in the blue line, but not so much that almost all of it is. So let's use our symbols again. I would say standard deviation is about 70 because about 68% of the data falls within 70 values above or below the mean. And that's what the standard deviation does. It tells you how spread out the data is. Okay. Hopefully you have some ideas on mean and standard deviation. Number 3 says, following are the number of calories in a basic hamburger, one meat patty with no cheese at various fast food restaurants across the country. Okay, so we've got lots of data. If you count it up here, there's actually 32 data values. That can help you when you're inputting. Part A says, input these data into L1 on your graphing calculator. Use one variable stats to calculate the mean and standard deviation. So I already did this to speed things up, but if you want to pause the video quick, you're going to go to stat, which is right here, stat. You want to edit again. So stat edit. And clear out anything. Remember, if you've got stuff in these other pieces over here, hit clear and enter, and it'll clear everything out. And then in L1, you just want to go through and type all of these in. So again, pause the video for a second, type these in. If you get all of them right, the last one you type in should be at L32. Okay, so I'll let you pause the video on this screen for a second and type it in. Okay, so assuming you've got this typed in now, the next thing you're going to do is you're going to go to stat, calc, and we don't want any of the regressions this time. We want one variable stats. We're never going to use two variable stats in this class, only one variable stats. Okay, so if you have a new calculator, it should say list, and L1 should be there where you just typed everything in. If it's not, you can change it. Hit second one for L1. Frequency list should be blank. And then calculate, hit enter, and you should get that screen. So I'm just going to write that when it said list, we wanted to say L1. And for now, the important thing is that frequency list is nothing. Keep that blank. Okay, now for those of you with an old calculator, let me change what it looks like real quick. I go to mode and change it to classic. Old calculator is somewhat similar. You're still going to go stat, calc, one variable stats. Oops, this isn't even an old calculator. No, oh well. Sorry, I can't show you. But old calculator, when you do one variable stats, it'll just say one variable stats, and you can just hit enter. Okay, so I want the mean and the standard deviation. I get a lot of information. The mean somewhere on the screen. Where is it? It's the first thing, because that's x bar. So x bar is 665.3125. Okay, so there's your mean. And remember what standard deviation is. Do you see standard deviation on here at all? It's right here. So I got a little x by it, but the standard deviation of the x values is 278.963-ish. So this is standard deviation. That's about equal to 278.963. Okay. It says create a histogram on your graphing calculator. Describe the shape. Okay, so if I want to do a histogram, I got to follow these directions. I go to statplot1, and before I move, maybe I should mention, most of the things on the screen we're not going to use. So this number, this number, this number, I'm not going to use. N equals 32 means the number of values. The Q's, if I arrow down, this stands for minimum. The lowest value is 240. Quartile 1, median, the middle value. Quartile 3, and the maximum value. I'll talk more about some of these in a second. But anyways, let's draw a histogram. Go to stat plot. So I'm going to do second y equals, go to stat plot. I'm going to go to 1. I'm going to turn my plot on instead of off. I'm going to select histogram. So now when it says type, a histogram is like those boxy things you've been seeing. So if I hit enter, I can do histogram. It only gives me L1 as an option. Good. Everything else is set the way it should be. And now if I go to zoom 9, and let me clear out anything else I have in here. If I go to zoom 9, I get a nice little histogram. So let me draw what that is quick. It doesn't have to be perfect, but the histogram looked something like this. It had like 4 boxes here. We could say it says describe the shape. I would say that's roughly symmetric. It's not bell-shaped. You could make a case maybe that it's slightly skewed right. Okay, so slightly skewed right. There's some high values over here, but there's a bunch of high values and they're kind of clumped with the other ones. So that's why I would say roughly symmetric. Okay, now let me give you a caution. We just turned our stat plot on. Look what happens if I go to stat, edit, if I clear out everything in L1 and get rid of it, my calculator's still fine. But let's try to go graph something. If I graph x squared and hit graph, there's that invalid dimension, invalid dim that some of you have seen before. What that means is it's trying to draw a stat plot because the stat plot's still on, but L1 doesn't have anything. It has an invalid dimension. There's nothing in L1. So that's why you're getting that sign when I go to graph. So anytime you turn a stat plot on, when you're done with the question, you should turn it off again. And then when you go to graph, it'll work like normal again. I should go zoom standard at least though. See, now it doesn't say invalid dimension. Okay, last page. If you're given a frequency table rather than just a list of data, we need to slightly alter what we do on our calculators to determine the mean and standard deviation. The table below displays the number of siblings of 20 students in a class. So when you have a frequency table, it's kind of just a way to clump all the data together. This tells you that there's 2 people with 0 siblings. So if I was going to list out the data like I did on the last page, we'd have 2 zeros, and we'd have 5 ones, we'd have 7 twos, etc. Okay, so if I want to put all that in, you could just type it all into L1 like that, or you can enter the number of siblings into L1 and the corresponding frequencies into L2. And the calculator has a way to know that you're looking at a frequency table. Okay, so here I'm going to go to Stat, Edit again. In L1, I'm going to put 0, 1, 2, 3, and 4. And over in L2, I'm going to put 2, 5, 7, 4, 2, corresponding frequencies. Now, most of this is going to be the same, but you have to tell it you're looking at a frequency chart. So now I'm going to go to Stat, Calc, one variable stats, just like I did last time, but I'm not going to leave frequency list blank. I need to put L2 there. So second 2 gets me L2. And then I can calculate, and you can see the mean, it's 1.95, and the standard deviation is 1.117. Okay, so let's first off write some notes about what we did. After I typed it all in, we went to Stat, Calc, one variable stats. Again, we always use one variable stats, never two variable stats. List should have had L1 in it already, but now you need to write frequency list, and you want to put L2. If you have an old calculator, when you go to Stat Calc one variable stats, you'd see one variable stats pop up on your screen. Don't just hit enter this time. You have to type L1, comma L2, and then hit enter to tell it you've got a frequency test. Okay, so again, so the mean was 1.95, the standard deviation is 1.117. So mean is 1.95, standard deviation is about 1.117. So that means the average is about having 2 siblings, and 68% of the people surveyed, if you go one out from that in either direction, have between one higher than 2, which would be 3, or one less than 2, which would be 1. So 68% of people have between 1 and 3 siblings, which makes sense. Determine the following values from your graphing calculator and your knowledge of statistics. So this is where I said there's some more information. Now mode. Mode isn't on the calculator anywhere. Let's fill in the ones that are. Quartile 1 is 1. The median is right here, that's 2. Quartile 3 is 3. Those we can get out of the calculator. Now median, let's start with that one. What do you think that means? Median sounds like middle. And the other thing that means is that 50% of the data is at or below 2 siblings. So if you list all of these data out and count in to find the center, you're going to be at 2. So half the people have more than 2, half the people have less than 2. What word does quartile sound like? Quarter, and a quarter is 25%. So the first quartile means 25% of the data at or below 25. So 25% of the people have 1 sibling or less. Quartile 3 is a quarter above the middle. So 75% of the data is at or below 75, or 3. So 75% of the people have 3 or fewer siblings. Now what's mode mean? You've definitely heard that word before. Mode means most. It's the most frequent data value. And you can have more than one mode because there can be a tie for which value occurs the most. But if you look at a frequency chart, you're looking for the highest frequency. 7 occurs more than anything else. So the number of 2 siblings occurs 7 times. That's the mode. If I listed it out, there'd be the most 2s. So 2 is the mode. To find the range, you always just take the max minus the min, and you can get that from the table or the calculator. And the calculator, max is 4, min is 0. So 4 minus 0 equals 4. You can see that from the table pretty easily. 4 minus 0. Interquartile range. That's quartile 3 minus quartile 1. So most of the data is going to be between the 1 and 3rd quartile. Quartile 3 was 3, minus quartile 1 was 1. So the interquartile range is a span of 2. Now variance isn't going to be the most important thing that you hear about this year, but variance, sometimes they ask it on the Regents, it's standard deviation squared. So in this case, the standard deviation we said was 1.117. This isn't a value that's in here. It's just another measure of spread. But if I do 1.117 squared, really we should take this full number out, but 1.1169 is all I can remember. If you square it, you're going to get about 1.25. So just think of variance as another measure of spread, not super important. Okay, last one, part C. How many students have a number of siblings that falls within 1 standard deviation of the mean? This used to be a common question on Regents questions. We need to be within 1 standard deviation of the mean. Think about what that means. That could be the mean minus 1 standard deviation, or it could be the mean plus 1 standard deviation. Both of those are within 1 standard deviation above or below. So the mean again was 1.95. If I subtract 1 standard deviation, 1.117, that gets 0.0, or sorry, not 0.0. It gets 0.833. And 1 standard deviation above would be 1.95 plus 1.117. That gets me to 3.067. So they're asking how many students fall between that number and that number. So this means between 0.833 siblings and 3.067 siblings. Well, what cases are those? Is 0 siblings between that? No, because 0 siblings would be lower than 0.8. But 1 sibling is, 2 siblings are, and 3 siblings are. 4 would be outside of that range again. So you have to add up how many students had 1, 2, or 3 siblings. So 5 plus 7 plus 4. That's how many students had 1, 2, or 3 siblings. So 5 plus 7 is 12, plus 4. Your answer would be 16 students. Okay, so there's no specific homework on statistics tonight, but hopefully that gave you a good overview and reminder of some of the things you should have already known. In next class, we'll start the Algebra 2 statistics.